So as you know, this is our last class period. Tomorrow's the last day of classes, and then a week from Thursday we have a final exam. I will have office hours on Thursday this week and Tuesday of next week, but not next Thursday because I'll be here. Is it Tuesday?
Yeah.
Oh, good.
I think it's a normal class time.
Yeah, 3:30.
Oh, right. Okay, never mind.
Yeah. Yeah, that makes sense because finals start on Thursdays. They're only a week long. Yeah, I don't like giving the finals the last day of the finals week because it's like you get less time to get the grades in.
Is it a longer final than the midterm? Is it a longer test?
The final period gives you 2 hours.
Is the test long? No more questions.
It can be a little bit longer.
Just because since they're weighted, it's 2 hours.
So today's review, but first I want to talk a bit about the current assignments. And most of the issues were with the visitor pattern. Remember, the whole point of visitor pattern is, right, we can add functionality to a heterogeneous structure without modifying the structure once we've built in the visitor pattern, right? And keep in mind, we don't know what future operations we're going to add, right? Which means several things. We don't know what type of things those operations are going to produce. Strings, integers, objects, arrays of objects, right? We don't know. So we get a solution like this. It's like, well, since you're creating the visitor object in a method in the tree, you only get one visitor. Right? It's like, okay, here's in the tree, the root node, and a bunch of other methods I'm put in, and then like, oh, I'll call print, and it creates a visitor, and then it calls it root accept. It's like, well, you only get one visitor. If we want to create another visitor, we have to modify our binary search tree to add it. So what's the point of using the visitor pattern? Right? We can't, it's not possible to create another visitor and run it on the tree without modifying our tree. The goal of visitor is we set the structure up in our structure, right? We set up the accept and visit stuff. And then next week I can implement a new visitor, right? And have that visitor visit our binary tree. Can't do that here, right? So no, we don't want that, right? And then it's returning a string. So yes, the visitor you were to create for the assignment created a string, but that doesn't mean the visitor we're going to create next week is going to return a string, right? Maybe I just want to count the number of nodes. Maybe I want to count the number of nodes or number of characters in the tree, right? So I want to turn an integer. Now what do I do? So no, we don't want, and then the print name is like, that's just what the one visitor returns the representation. It doesn't mean the next visitor is going to do that, right? So Don't want that either. So just put an accept method on the tree and pass in a visitor. And now the visitor I create next week, I can pass in that method. There's no need to return a value. Why? Well, because we don't know what value is going to be returned. It's like the builder pattern, right? The same thing as the builder pattern. We don't know what type of thing the builder is going to create, right? So we pass the builder to the director and give directors instructions, and we're all done. We ask the builder to give me the thing back, not the director. Right? So we can create, a new tree, you add a bunch of stuff to it, create some sort of visitor and pass it into the accept method, and then we're done. We ask the visitor to give me the value back. That way, if it's a string, we know if that visitor A returns a string, when you get result, it returns a string. If it returns an integer, get result returns an integer on that visitor. We don't even have to call it the same thing in all visitors. We just have a way of asking a visitor to give me a result. And we don't even need to put that in the interface of visitor because it's going to return different things, right? So in Java, we can't put it in the interface. In Python and Ruby, we can, but we can't in. And then we actually have 3 different elements to our structure, the entire structure, and then inner nodes and null nodes. So we could also just have the visitor visit the tree and then visit all the nodes. What's that?
Is it okay if the accept function is associated with the nodes in the tree instead of?
Oh no, there's accept for the root too, right? But then how do we get it? How does the visitor get to the nodes? Now, what some people did is they had a get root method and return the root of the tree, so that outside the tree, I could then pass in the visitor, right? But now you're exposing the internal structure of your tree, right? And again, from the very beginning of the course, we talked about object is data operations, and we talked about the Dilbert principle, which encapsulate things, right? So why should the client have to pull the node out to pass a visitor? Just ask tell the tree, here's a visitor, you do the right thing, and then when I'm done, I'll get the answer out of my visitor. There's no need to expose the node to the outside world just for the visitor pattern, right? You just put a method in the tree to that is no, right? So here, there's 2 patterns intersecting, right? One is the null pattern, null object pattern, and the visitor pattern. The point of the null object pattern is to avoid checking for null, right? So here we're checking for null. And the goal of the visitor pattern was to, explicitly make the case for each different type of element in our structure, right? So don't need that, but just have a visit method for each type of element in your structure. What happens if we want to add a new type of node in our tree? This way we're going to have to go inside and find all the places. Well, here it's explicit, right? Here's all the places, here's all types of nodes. Now, the Java people, right, we can get by with, on the visitor pattern, having the name of all the visit methods the same, right? Visit, then having the type of the argument be the one that selects which method is chosen, right? For the Ruby, right, and the Python people can't do that. No, because in Python and Ruby, right, your parameters are not typed. They just have names. So then you have to actually use explicit naming of the function, right? Visit null node, visit, binary node, visit tree in those languages. Otherwise, you end up doing things like this: visit node, and then inside you have to check what are you. I go, what? I'm in a tree, and so you expect certain things to be part of a tree, right? Visitor does not really sound right to be a field in a tree. And then array list, what? I mean, either we store as a node structure or we can store it in an array, right? Making sure the array is ordered in the right way.
I have done that before, the list and the tree, because in C++ it makes it easier to clean up. But in like a language like Java, I don't.
Yeah, I mean, how does it make it easier to clean up? Getting rid of the
Instead
memory?
of having to traverse the node to traverse the tree to delete all the nodes, just
delete them all. Yeah. So yeah, I mean, Java does make sense to me. A binary search tree is not a type of a node, right? It gets confusing because now, right, if the binary tree extends node, then it already has a left and a right and a value, and then you have the root node. It's like, why do you need both? For the Java people, what method do you use to add something to a tree? Well, now we have to be careful here, right? Add is what you use in a collection. In a tree structure, they use put. And the reason they use put is because typically they use a tree to implement a dictionary. So then you're actually adding a key and a value. Now, in our case, right, we're just adding a single value. There's no key value, so then it should be add, yeah, not insert. And why is that? Why does it matter? Anyone? Yeah, one is to be consistent with the library, right? Now, if we also made our BS tree extend collection or some other thing, then it would work, right? Plus, it's one last thing to remember. When you go and look at the Java API, it's huge, right? And now do you have to remember, oh, Java uses add and our classes use insert?
That's a question I have, because C# does it this way and Java does it this way, and it throws me off. Because they use size for like array lists, and then they use count for arrays.
Yeah.
And then you have to remember which is which. Is there, because they do it the same way in C# and Java. Is there a reason they did it like you said, it's just one.
It's annoying, yeah. Yeah, I don't know. But it's definitely, I mean, it's just,
I get along more than
yeah. And it's, I mean, it is true that building a huge library like that, it's hard to be completely consistent. But in the Microsoft world, I mean, come on, Microsoft, I mean, they've got, it's not a small company, right? So they should be able to get the force. And when Java came out, you know, Sun was a fairly big company. The Java team wasn't that big, but it did, initially it was pretty small, but after a while it was huge too. So, yeah, I don't know. And so one issue was like, oh, if we're using a null object, how do we actually add things, right? The problem is you say insert or add, and it goes down and down, and it ends at the null object. And now how do you really want to add it in one place up, right? So there's a number of ways for doing that. One is you rebuild the tree, which many people did, right? As you go down, you create the node and you add it up. You can give a parent pointer, so when you get down the bottom, right, the null object can say, okay, tell the parent, add this thing to yourself, right? We can convert the null node to a real node, which gets complicated because there's no way of doing that directly in Java. So what you have to do is you have to use which pattern? Yeah, the bridge pattern, right? Then that gets complicated because the bridge does all the work, and then the shell, and then, or we can just forget the null node, right? And you say, you know, if left is null, which is not a good thing to do on assignment when you're trying to show you know how to use a null object pattern, right? Now, it's true that when you build a binary search tree, you probably don't need the null object pattern, right? So it's overkill. But they rebuild it, right? If we can just, you know, our tree, we just add something, well, it's call add on the root and have the root return the value and assign it to root. And when you add it the first time, you're calling add on a null node, and what the null node does is it says create a new regular node and return it. And then the binary node, I mean, you have to go left or right, right? And then, right? So we don't need to check for no, right? We just, in this case, we just go down the tree and each node does the right thing. Like as parent pointers, you can either give each node the parent pointer, or when you call add, you pass it on. And then in the null node, you just tell the parent, okay, if you've got a separate method, you can now add yourself here, not anywhere else. All right. And then it's a little more complicated, but you have two methods. One is where you pass it down, another one where you actually insert it.
The null node.
Protected if it's in the same package, yeah. Has to be in the same package, yeah. It should work. Questions? Like I said, most of the problems are with the visitor pattern. And I did it in Clojure too, but some of the patterns don't make sense. There's a node, insert method, doing it directly. I mean, just the one interesting thing here is, of course, the structures are immutable. So you go down the tree, get to the null, and then you build it back up again. Right? That's why, you're creating here a new element. And just go down to back up again. It was one of the weird things when I decided to teach a course on functional programming. I started doing all my assignments in this class using Clojure, and the first one had a tree structure. And I was like, wait, how do you build a tree structure in a language where all your structures are immutable? And I had no idea at first. So are there questions about next week?
Shave.
What color would you like to get?
I didn't like choices. Something about pink.
I think the choices are pink, yellow, and green. What? Is it in the right column? Right.
So the previous finals seem to be more focused on rank. Even is that
So typically, I do a bit more focus on material after the midterm.
I guess that's part of my question. I don't know. A lot of, I might even say, was not.
Right.
So we might see a significant final we've seen.
Somewhat, but
Everything.
yeah. Any other questions? We didn't only cover basically one architectural pattern, right? The MVC. Yeah, those are MVC related though, in my mind, yeah.
So for mediator, all the examples that we've looked at, I don't think it's always this. The mediator is basically just a, and then all collaborate, really just some, because all the say, yeah. Is that a limitation of the pattern, or is that just?
Well, first of all, it's not quite observer, right? It's not the observer pattern where the the element says I've changed and then the notification, the object can call directly a method on the mediator.
Examples
Right.
that we've looked at? It's just, I guess in theory they can.
Right, yeah,
It's kind of interesting. The book example, they all widget,
right,
and then they pass themselves as an argument,
right.
and then you have basically control coupling,
What it is.
what it is,
It's,
and then you have a big if statement.
right.
So,
Yeah, I don't think the mediator pattern has to be just the observer pattern.
then you made a comment on one of your slides that in ReactiveX, a lot of times the mediator is. That was one of the slides.
Yeah. Off the top of my head, it's hard to think of an example of that, but
That makes sense to me.
yeah.
It's the examples we looked at.
Then you have to keep in mind that you've got, if it's a notification, even if you've got 10 sources, right, they'll have to contribute to the same stream, and then you have to figure out who responds to each one.
Yeah, so it's almost like an inversion of
Right.
one of an observer.
Right.
So if we're asked, this pattern is good for, are those typically limited to four or property value object?
Well, we definitely have a lot more information on the gang of four patterns, right? So I can ask you more detailed questions on those.
The answer could, you might say, what pattern?
Right. Yeah.
that long. Kept getting more and more.
Oh, right.
Language and
Right.
I mean, is that
Not really, no. I mean, it's
a good thing?
patterns, yeah.
And then I noticed none of the finals you went all the way back, but that is still.
It's still game, but like I said, I tend to try and focus more on later material. But, there's not that much more time, but a lot more material, right? So you can't examine everything in the same level of detail on the final.
Did we get further?
No. At some point, it looked like we were going to be ahead, but any other questions, issues?
In the work we just did, the factor, is that considered the flyweight pattern, or is that because I'll return it really caching? Is that considered a minor case of flyweight pattern?
Yeah, it's basically the same thing, right? I mean,
It's still simplified.
yeah,
It's just a cache
right.
based on.
Well, how they're different from the character flyweight?
There's no expected state.
Yeah.
Started with an immutable.
Right.
So
Yeah.
Peel up. Related to flyweight. I noticed they talk about being able to share versus not share,
right?
But they don't talk about immutable. Is there a reason, and is there ever a case where your shared objects are?
Well, immutability was not a big thing back then. That's probably why they don't talk about it. Right? I mean, if you remember, the book came out and published in '95. And so functional programming was this thing these people would do over here. I mean, they're like hiding in their offices. And the people who wrote these were the people who were leaders in object-oriented programming language movement. So, I mean, their focus was on object-oriented programming. And yeah, at that point, immutability was just considered too expensive.
But it's safe to say that the flyweight would not modify the share.
Right, yeah. Uncle Bob or Robert Martin once characterized evolution of programming languages as not what they add, but what they subtract. And immutability is one thing. They're subtracting the ability to modify objects, right? Because processors are now faster enough that we can manage the garbage collection that results from having to recreate the object. And replacing the goto with while loops and for loops, again, we're we're removing functionality you used to have.
Actually, one of the topics from when you research the aspect,
Yeah.
they were talking about how it's a joke command. One of the criticisms is that the joke command come from or something, where it's like the opposite of a go-to.
Right.
So execute the statement, but
Right. 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 Well, if no one else has questions, we can end here. And what's the also the question is, what's the most commonly used pattern? The most commonly used pattern in industry? What's that?
Yeah, what are the most patterns?
What patterns are used most? That's a hard question to answer because they typically don't report right which patterns they use. I know Ralph Johnson, one of the authors, says the most common pattern is template method. Well, but see, the issue is you can use the template method multiple times in a project. Whereas a big ball mud, you only get to use once per project, right?
you probably have to observe.
Yeah, observer is pretty common, yeah. Flyweight, not so much.
From this point forward, I'm going to try to use factory, always stop the factory. But in the context of trying to program interfaces, figure out that.
Yeah.
It also reduces coupling, where
Right,
everywhere you do new concrete,
right.
and I've got all I mean, C++ really can't program the interfaces if you have to.
Right. Yeah, there's actually, at least one person I know really complained about the design pattern movement. He said, yeah, really most patterns are language issues, not design issues. Because a lot of times it's just, like you said, there's certain things you just can't do in C++ because you have to worry about memory, right? And then in Java, the patterns work well, but you go on the list and it's like a lot of patterns you don't need because the language has other features built in that removes the need for those patterns. And then when you move to functional programming, it's like, oh, completely different. And so,
Yeah, it'd be interesting to see again remodify or even just for lamp because
that's
a lot of the patterns really change when you start.
right. Yeah. Again, so the question is, do weakly typed languages or dynamically typed languages use defined patterns? Yeah. The patterns, some of them change, right? Um, for example, in small talk, right, the factory method just becomes, just, create the object. You just return the name, the class itself. And then once you have the class, you just send a message new to it. So we can spend another 20 minutes trying to think of questions, or we could go home and you and I can have a private conversation, right? Well, I hope you'll find this course useful. Um, and we'll see everyone one last time, right? This semester.
So on the homework, I know you don't give points back or whatever, but that's fine. But you put, I added this to the is left child because I added a new visitor.
Yeah.
And I needed it for the new visitor.
Why?
Because in order to get